Okay, fellow pilots, elevators, and anybody watching this tape, we're flying on Pilatus, PC-12, PC-12. Flight level 220, flight level 220, cruising at about 190 knots indicated, which is about 260 true airspeed. Our ground speed is about 230, which give us about 30 knots of headwind over to
3669, flight level 200.
Omaha, Nebraska.
3669, Chicago Center, Roger. Maintain 16,000.
What we're going to do right now is we're going to talk about the power plant on this aircraft. So, when you read the description, this airplane is powered by a Pratt & Whitney PT-6A-67B, which is a lightweight reverse flow free turbine engine. In addition to the gas generator section, the PT-6A-67B incorporates a power section with a power turbine and propeller reduction gearbox, an integral oil system, and an accessory gearbox for mountings for various accessories.
Flagship 3964, I couldn't get the score right here, maybe...
So it's a turbine engine, we know. It's got an accessory gearbox connected to the turbine.
That's it.
It's a lightweight aircraft engine, and it's got a free turbine, which means the shaft is free spinning. Okay? Now, let's talk about induction. The air enters the compressor through an annular plenum chamber. The compressor consists of 4 axial stages and a single centrifugal stage. So, it's got 5-stage compressor. When the air is coming through the inlet, it's compressed 5 times. It's going to be compressed 4 times via the axial stages and 1 time via the centrifugal stage. 5-stage compressor. Stator vanes between each state of compression diffuse the air, raise its static pressure, and direct it to the next stage of compression. So as it's entering the engine, it's compressed. Static vanes going into the next stage, compress, again next stage, compress. So it's got 5 stages of compression. That's why we're flying at flight level 220 and we're getting so much power or torque out of it, because 5 stages of a compressor. It's not normally aspirated, it's compressed, it's turbo, you know, it's
Pilatus 900 Hotel Sierra, contact Chicago Center 127.8.
127.8, Pilatus 900 Hotel Sierra. So long. Good evening, Center, Pilatus 900 Hotel Sierra, flight level 220, direct India Oscar Whiskey.
900 Hotel Sierra, Chicago Center, Roger.
Chicago. Okay, back to our power plant.
Eagle 2751, cross halls at maintain 12,000.
Halls at 12,000.
From the centrifugal compressor, air flows through a diffuser tube, then changes direction 180 degrees as it flows into the combustion chamber. A compressor bleed air valve installed in the gas generator case at 3 o'clock position automatically opens to spill interstage compressor air to prevent compressor stalls. So,
Delta 1306, center maintain flight level 2.
as the air is going in, it's actually reversing course at 180 degrees in the inside the engine. And there is a gas generator.
AC 5878 Chicago.
Oh, there's a compressor bleed valve.
Touching nothing, AC 5878 there.
That opens to spill interstage compressor air to prevent. So in order to prevent compressor stall, which you never want on a turbine engine, there is a bleed valve installed inside the engine. Now, the combustion chamber consists of 2 perforated annular sections bolted together with a large exit duct. Compressed air enters the combustion chamber through the perforations, where it is mixed with fuel and ignited. The rapidly expanding gas is directed through another 180-degree direction change in the turbine. So, compressor changes direction 180 degrees. and then combustion chamber, ignites, and then reverse another 180 degree into the turbine. The turbine is spinning, connected to the shaft and spinning the compressor that constantly compresses. So it's like a continuous flow. It's always exactly. That's why it's so efficient, less maintenance, more TBO, more horsepower, less maintenance, less bearings, no pistons. It's not a normally aspirated or, piston. It's not piston powered. Okay, the turbine consists of single-stage compressor turbine and a two-stage power turbine, so there's 3-stage on the turbine side. As the gas exits the combustion chamber, it's directed into the compressor turbine, which powers the compressor. For the compression turbine, the gas is directed to the two-stage power turbine, which derives the propeller via the propeller reduction gearbox. Engine inter-turbine temperature is measured between the compressor and power turbines, okay? So, inter-turbine temperature. This ITT is inter-turbine temperature. You're measuring the turbine temperature. Gas flow is directed into the exhaust ducts from the turbine. The exhaust duct has an annular inlet which leads exhaust gas to bifurcated duct connected to 2 opposed exhaust ports. Those are the 2 exhaust ports on the sides, okay? Exhaust duct is made from the heat-resistant nickel alloy metal and incorporates mounting flanges for the exhaust nozzles, which is the ones on the sides. There's a picture.
Eagle 2751, contact Chicago
the
approach,
engine.
119.0, good day.
Okay, that's the propeller shaft.
19-0, Eagle 2751.
Intake, this is exhaust. And let's see.
As a pressurized 5 times rich.
Accessory gearbox, combustion chamber. Magnetic chip. Let's see if we have. Okay, there it is, right there. You see, this is inlet from the top and the bottom, going into the compressor, 5 stages of compression, and then 180 degree, you see, reverse course, back this way.
To give me the thrust.
And then
Compressed.
goes another 180 into a turbine, and 3-stage turbine.
20 miles north of Knox,
And then
the other side of Knox,
exhaust this
2000, altimeter 3004.
3004, 20 north of
Okay, the propeller shaft
Delta 1306.
is right here.
Parallel by 3181, checking on 20.
And there's an accessory gearbox which actually slows down the propeller, because the turbine may be spinning much faster than the propeller, so the accessory gearbox is actually slowing. Then you have a propeller governor mounting pad and a propeller shaft, so there's a governor that controls the speed to precisely 1700. Okay, now, let's talk about the air induction for the engine. 1 hour to Iowa. Air inlet consists of crescent-shaped metal leading edge through which hot exhaust is passed to prevent ice accumulation. Exhaust gas is extended from the left-hand side of the exhaust stub to means 1.5-inch diameter pitot probe inserted in the stub itself. It then passes through the lip consisting of a sealed chamber before exiting the right stub through 1.5-inch discharge tube. The probes are connected to the exhaust lip. Inlet duct which connects to the inlet to plenum consists of diverging nozzle following the same general shape as the inlet tip. They're talking about the air induction, how it's all, how it's going into how the air is going into the engine. There's an inertial separator of a fixed geometry design and provides engine induction system protection when operating in icing or foreign object damage conditions. So there's an inertial separator. When you're going into icing condition, there's a way to prevent icing going in and ingested into the compressor. It can be used for takeoff when operating in FOD environment. FOD,
25,
foreign object damage on the ground, gravel, grass, you can use that inertial separator when you're on.
To arrival, descend and maintain, flight level 220.
It's comprising of a fixed number 2 mesh screen attached to the rear wall of the plenum covering a percentage of the inlet area, a movable outlet door, and electrical actuator situated directly up oil cooler outlet exit and converging by bypass duct.
Eagle 3181.
In normal operation, non-icing, not FOD, the outlet door is closed, which seals the bypass and provides induction air with single flow plenum and engine through the porous number 2 screen.
2841, that was for somebody else.
Yeah, I know, because we're going to 22. I was wondering about that. Okay. So we're going direct Watson to 220, Eagle 2841.
Thanks. Eagle 3181, just verify you got hulls out of 21.
Yeah, out of 21, we're direct hulls, Eagle 3181.
Okay.
We're coming up to the lake over here.
Actually, Eagle Flight 2841, you can go direct hulls now.
Okay, direct to hulls, Eagle 2841.
So, that switch over there in the panel, you see inertial separator? There's two positions, closed and open.
Correct. That's for the de-icing.
Correct. That's to prevent ice from going into the, not just ice, FOD too, which is foreign object. Yeah.
Eagle Flight 3181, cross hulls at 12000, altimeter's 3004.
3004 hulls at 12000, Eagle Flight 3181.
Normal condition is closed.
Okay.
In icing condition, you can open the door.
Basically, it goes in
and you'll have a green light here. Let's see. Open. When the door is fully open, you'll have a green light.
And
the door is open. There you go. Green inert separator. Now it's icing condition, so you open it. Normal condition, you keep it closed. If you turn the switch on and this green light doesn't come on, there's a problem with the system. You gotta be avoiding, avoiding icing condition.
Yeah, avoid icing anyway, but
sometimes you have no choice. You have to climb through the clouds and get up to altitude where it's nice and smooth. So, okay.
Right here. So that's tail.
Yeah, right there. Yeah. Then you have the PCL, which is the power control lever.
That's this, right there.
We talked about it earlier. It has the PCL, which is the power control lever, has flight and ground.
Yep.
And there's an idle detent. When you go all the way here, you have to lift it up to go to beta, which is ground.
Correct.
You never want to do that in flight. Always keep it in flight. Sure. Flying, okay?
Delta 1306, flow to 300 knots, contact Chicago approach 119.0, good day.
19-0, 300 knots, Delta 1306 with you.
Over here you have a warning on the PCL. Do not move the PCL below the idle detent when the engine is not operating to prevent damage to the control linkage.
Second. Do not operate what?
You don't want to go below the idle detent when the engine is not operating to prevent control linkage failure. So you don't want, if the engine is not operating, you don't want it below the idle detent. PCL operation after the idle detent never permitted in flight or when engine operation is controlled by the manual override lever. This is a manual override lever right there to the left. Yep. Always keep it in flight, never go beyond idle detent back in flight, okay? Now, let's talk about the manual override for that PCL. Manual override lever, MOR, is located on the center console to the left of the PCL. The manual override lever controls the engine power in case of pneumatic failure of the engine fuel control or in case of PCL system failure. So if the PCL is failed, you can manual override and use this lever to control the power manually. The MOR lever is an emergency device and it is possible to exceed engine limits if the MOR lever is operated too fast. However, if the engine limit have been voluntarily exceeded, it will allow the crew to continue safe flight and landing if the engine failure is in flight.
Direct to 5th.
Partial power loss emergency procedure is followed. So,
2841 cross hulls at 12,000.
if this fails, you can use this, but you have to make sure you don't over torque or over exceed the engine.
G34 is with you about the level 240.
So this is like
emergency power lever. Emergency power lever.
Watson 2 arrival, descend and maintain flight level 220.
Descend at 220 watts, directly to Watson arrival unit.
During normal engine operation, the MOR lever is in the full aft or off position. So full aft, off position. That's normally. In the case of a possible PCL, which is power control lever failure, PCL should be exercised to check engine response. If this fails, you can try and move it a little bit, see if the engine works. If it doesn't work, you have to use the manual override.
Take care, 3181.
United 234, you probably know it, but 243 is right behind you.
Thanks, got it.
Observe the engine limitations by making adjustment for the MOR lever. Do not permit NG to fall below 65%.
That's at 613.
See here, you don't want to get the RPM too low. Keep it above 65. After touchdown, select cutoff feather to avoid exceeding ITT limits. So with manual override, you may exceed the ITT limit. So as soon as you touch down and you're safe,
23 now,
idle cutoff.
11 southwest.
All the way. See ground idle, cutoff feather, all the way back. Shut off the engine.
United 234, maintain 280 knots.
280 now.
So this is only for emergency. Over here, caution, the MOR lever must be in the off position prior to engine start to prevent a hot start, so wanted it off. PCL operation after the idle detent is not permitted when engine operation is controlled by the manual override lever. So if you're doing manual override, you want to be up here. You don't want to be past the idle detent.
United 243, roger, you're clear to O'Hare Airport via direct Watson 2, arrival, descend to flight level 230.
Down to 230, direct Watson 2, arrival, United 243.
United 243, I'm sure you know it, but company 234 is right in front of you.
243, affirmative.
Purchase 438, 26.5 for 30 to set of Kokomo.
And that's going to conclude...
Purchase 438, make that crossing and then proceed direct.
The engine.
I will do the crossing and then direct.